Hello everyone, this is Mr. Underkoffler. Today we're going to be looking at the guided notes called Intro to Factoring Expressions, Finding the GCF. Alright, let's do some review on some vocabulary here. A factor is a number or algebraic expression that divides another number or expression evenly with no remainder. For example, the factors of 9 are 1, 3, and 9. Now how did I get that? Well, because 1 times 9 would make 9, and 3 times 3 would equal 9. These are numbers that can divide into 9 evenly without having any remainder. Those are what we call factors of a number. The greatest common factor, which is abbreviated as a GCF, is the greatest factor that two or more numbers have in common. This is key. It has to be factors that they both have in common, and we're looking for the greatest of those factors that they have in common. For example, for the set of numbers 10 and 25, their GCF is 5. Now, how do you get GCF? Well, we're going to talk about that. There's many different ways of doing it. I'm going to highlight two ways. The first one is one that you probably saw back in maybe elementary school, where you list all the factors of each number from the original problem. So, for example, find the GCF of 36 and 84. So what I did is I figured out 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times itself. Those are the factors of 36. And then I found the factors of 84. Now, yes, I purposely chose an example here that had lots and lots of factors. As you can see, and you can go ahead and circle these numbers here with your pencil, the greatest factor that they have in common was 12. Now, there is a potential issue with this method, and hopefully it's kind of obvious to you. What if you didn't figure out all these factors? And what if you happened to miss one of them that should have ended up as being the greatest factor in common? Like, what if you never figured out that 12 was a factor of 84? 12 times 7. If you don't ever figure that out, then you're not going to get the greatest common factor of 36 and 84. You're not going to get it because you don't even have 12 listed as a factor of 84. So that's the issue with trying to do this method. So what I want to do is show you an alternate method that kind of uses the same ideas of the listing method, but in a more efficient way and therefore quicker way, which you'll probably enjoy. So here's the method. We're going to start with the greatest factor of the smaller number from the set of numbers of the original problem that we're trying to find the GCF of. And then we're going to go from there. I have the steps spelled out for you here in this box. We're going to start with the smaller number. We're going to find its greatest factor. Then we're going to check, is it a factor of the other number? If not, then we'll go to the next greatest factor of the smaller number. And then we'll check if that is a factor of the other number. And then we were going to repeat this process for as many times as we need to until we finally find a factor of the smaller number that happens to also work for the other number. So here's an example on the right. Get your pencils in your hand because we have some blanks to fill in. And you are allowed to use your calculator when helpful to use it. Okay, so like I said in the box, we're going to start with the smaller number. So I think we can all agree the smaller number here is 36. We're going to start with that one. And we're going to think of its greatest factor. Now you're like, well, how do I get the greatest factor of a number? Real simple. 1 times the number gives itself. It equals itself. So 1 times 36 is 36. 36 is the greatest factor of itself. I mean, that's pretty self-explanatory. If I was talking about 25, the greatest factor of 25 is 25. The greatest factor of 84 is 84, but we're starting with the smaller number here and thinking of its greatest factor. Now, here's what we do with this. We ask, is 36 a factor of 84? How would I know? In my calculator, I can check by taking 84, the other number involved here, divided by the factor that I'm currently checking. Fill that blank in. Use your calculator. What happens when you take 84 divided by 36? Well, you're not going to get a nice whole number answer, are you? You're going to get 2.3 repeating. So what does that mean? That means 36, is not a factor of 84, because if it was, it would divide into it evenly. Remember how we talked about that at the top of the page? That's how we know what a factor is. So If you divide and you get a decimal, then no, it is not a factor of the other number. So what do? I go back to the smaller number, and instead of thinking of its greatest factor, because we already tried that, didn't work, we go to the next greatest factor. Now, how do I do that? And instead of thinking of 1 times 36, I'm going to think, well, could 2 times something give me 36? Well, in my calculator, I can take 36 divided by 2, which will give me 18. So 2 times 18 equals 36. This means 18 is the next greatest factor of 36. And now what I'm going to do is I'm going to check to see if 18 is a factor of 84. And the way I will check that is dividing in my calculator. Now make sure you're filling in the blanks as we go through this. But check in your calculator. Would 84 divided by 18 give you a whole number? No. Hopefully you checked in your calculator. It gave you 4.6 repeating. So what does that mean? It means 18 is not a factor of 84. Big fat no. So what do? I just keep repeating this process. Instead of 1 times 36 and 2 times 18, well, could 3 times something give me 36? We'll take 36 divided by 3. And you get 12, which means 3 times 12 gives you 36. So that's the next greatest factor of 36. And what I have to do is I have to check to see if that is a factor of 84. And the way I do that is in my calculator, I take 84 divided by 12. Now, what do you get when you take 84 divided by 12 in your calculator? You get 7. That's a whole number. So what does this mean? It means, yes, 12 is a factor of 84. And since we already saw that 12 was a factor of 36, it was the third greatest factor of 36, and it happened to also be a factor of 84, then we know then that that is the greatest factor, that the two original numbers, 36 and 84, it is the greatest factor that it has in common. And again, this is kind of like the listing method. You eventually get to that 12. Notice we did 36, 18, 12. So we were kind of working our way down from the biggest factors of 36 and then going down. And we're checking each of them to see if they're a factor of 84. So it's kind of like the listing method in some ways, but it's a much more efficient way of doing it. So, before we go to the next page, very bottom of the first page, can the GCF actually include a variable or possibly multiple variables? Yes. If there's a variable or more than one variable in common from the two original terms that you're trying to find the GCF of, then yes, you could have not just a numerical part for a GCF, but you could also have a variable part with it as well. And I promise you will do some examples of that coming up real soon. So turn to the second page. We are going to do one or two of these problems together, and then you're going to try the rest on your own. And again, as the directions say, you may use a calculator to help you when needed. Just don't use a calculator for really easy stuff. All right, let's find the greatest common factor for each of these two terms. Now, we start with the smaller number. I think we can all agree the smaller number here is 26, okay? So, what's the biggest factor of 26? Well, think 1 times, boom, 26 would give you 26. So 26 is the greatest factor of 26. Now, in our calculator, we're going to check, is 39 divisible by 26? Meaning, if I take 39 divided by 26, do I get a whole number? Because if I do, then I'm done, and 26 is the greatest common factor. But no, if you take 39 divided by 26, you're going to get 1.5. So, boom, sorry, 26 is not a factor of 39. It is a factor of 26, but it's not a factor of 39. Therefore, it can't be the greatest factor that they have in common. So what do? I go to the next greatest factor of 26. Divide it by 2 in your calculator if you need to. 26 divided by 2 would give you 13. Is 13 a factor of 39? Well, I bet some of you already know. But if you don't, in your calculator, take 39 and divide it by 13, and you get 3. So what does that mean? That means 13, not 3, but 13 is a factor of 39. And since we know it's a factor of 26, This is the greatest common factor. Almost. Remember at the bottom of the page? The GCF could include a variable or maybe more than one variable if they are in common. Well, if you have a highlighter, you might want to highlight this. A is in common from these two original terms. Now, B is not. B is not showing up in 26A. B only shows up on 39AB. So don't highlight the B. The B is not in common, but the A is in common. So don't just say the GCF is 13. Say it's 13A. All right, let's do one more together. All right, 48N and 68. Who is the smaller of the two? It's the 48. Now watch out. It's not always going to be the first number. Spoiler alert, when you get the number 3, the smaller of the two numbers is 76. So you're going to actually start thinking of factors of 76 when you eventually do number 3 on your own. So kind of got you started there. But let's do number 2 together. The smaller of the two factors of the two original numbers is 48. So what do I do? What's the biggest factor of 48? Well, 1 times 48 is 48. Is 48 a factor of 68? Try right now in your calculator. Take 68 divided by 48. And you get 1.416 repeating. So no, sorry, doesn't work as a factor of 68. So go to the next biggest factor of 48. Divide it by 2. And you get 48 divided by 2 is 24. Is 24 a factor of 68? Well, I don't know. Divide in your calculator. 68 divided by 24 is 2.83 repeating. So nope. Not a factor of 68. So what's the next factor of 48? Well, could 3 times something give you 48? 48 divided by 3 is 16. And again, you can use your calculator for this stuff to help you. Is 16 a factor of 68? Ugh, no, 4.25. This one's taking a little bit longer, isn't it? Could 4 times something give us 48? Yep, times 12. Now, if you didn't know that, in your calculator, you take 48 divided by 4, and you get 12. Is 12 a factor of 68? Are you checking in your calculator? Don't let me do all the work for you. You guys should be following along here. 68 divided by 12 is 5.6 repeating. Oh my goodness, no, it's not a factor of 68. So I'm going to keep going here. Well, wait a minute. 5 times stuff should be numbers that end with 0 or end with 5. 5 times no whole number at all could be 48. You don't believe me? You can take 48 divided by 5 and you get 9.6. So, not 5 times something. Could 6 times something be 48? Oh yeah, 6 times 8. Hopefully you guys know your times tables. Is 8 a factor of 68? I don't think so, because I know 8 can make 64. Can't make 68. If you don't believe me, take 68 divided by 8. You would get 8.5. Could 7 times something be 48? 7 times 7 is 49. If you take 48 divided by 7, you get 6.857, yada, yada, yada. So sometimes it's not going to give you a number that's not a decimal. So when that happens, you can't use it. So could 8 times something give you 4? Wait a minute. Didn't I already have 8? Oh, I did. And it didn't work. So I'm kind of now at the point where I can start going back to the smaller numbers here. So I already used these guys. 7 didn't even work. Could 6 work? Well, is 68 divisible by 6? I don't think so. I know 6 times 11 is 66. So yeah, 68 divided by 6, that gives me 11.3 repeating. So that's no good. 5 wasn't even a thing here, because that didn't even give me a factor of 48. 4? Is 4 a factor of 68? Oh, it is. Did you try that in your calculator? 68 divided by 4 gave me 17. So this is one of those situations where it took a bit of time. And you ended up kind of getting to the same numbers we already had here. 6 times 8, now 8 times 6. So we're kind of working our way backwards And remember, if 7 times no whole number gave you 48, then you have to scribble out 7. Same thing with 5 times nothing gave me 48. So I had to scribble out 5. So I finally found out that 4 times 17 would give me 68. So 4 is the GCF. Does it have a variable part that's in common? Well, 48 has n. Does 68 have... No, there's no variable here at all. So no, there's no variable piece to the GCF here. Only on number 1, we did have a variable piece that was in common, but not so much on problem number 2. So that's something you always have to check. So don't jump to the next problem right away. Always check, is there a variable part that is in common? Okay, now that we did 1, 2, and the problem on the first page together, time for you to try some on your own. There's only 4 problems left, 3, 4, 5, and 6. So hit pause on this video, try those last 4 problems on your own, use the calculator to help. Make sure you're starting with the smaller number. It's not always the first number, like a number 3, the smaller number is 76. And always look to see if there's a variable piece as well that might be in common. So hit pause, do 3, 4, 5, and 6 on your own, and then hit play when you're ready to see how you did. All right, did you already try 3, 4, 5, and 6? I hope so, because here we go. Let's go over them. 1 times 76, but 76 was not a factor of 95. 2 times 38 makes 76, but 38 is not a factor of 95. 3 doesn't even work for 76 because you would get a decimal, so goodbye that. 4 times 19, and yes, 19 did work as a factor of 95. So the GCF is 19. Oh, do you see what I see? Literally, the C. It's there. It's in common from the 2 terms. So the GCF is not just 19, but 19C. Go ahead and fix it if you made any errors. How about problem number 4? The smaller of the 2 numbers is 28. So, oh, did you try 28? It actually worked. 56 divided by 28 is 2. So 28, which was the biggest factor of 28, happens to be a factor of 56. So yay, this one would get done super fast. Oh, is there a variable in common? No, x and y, not the same thing. So no variable in common, just 28. Problem number 5. The smaller number is 88. 1 times 88 is 88. Is 88 a factor of 110? Nope, gave you a decimal. 2 times 44. Is 44 a factor of 110? Nope, gave me a decimal. 3 times a decimal would give me 88, so can't even use 3 here. 4 times 22 makes 88. Is 22 a factor of 110? Yes, it worked. 22 times 5 would give you 110. So the GCF is 22. Oh, was there a variable in common? Yes, x was in common, so 22x. And if I'm going too fast at any point, feel free to hit pause. Feel free to skip back 10 seconds to hear something explained again. That's the benefit of watching a video. You have those capabilities. And finally, problem number 6. The smaller of the 2 numbers is 63. Was 63 a factor of 98? No. So 2 times a decimal will give me 63. 3 times 21. Is 21 a factor of 98? You tried it? Nope, didn't work. 4 times the decimal would be 63, so we have to go to 5. 5 times the decimal will be 63. 6 times the decimal is 63, so no good there. 7 times 9 is 63. Is 9 a factor of 98? No. You're like, why do you have a check mark here? Because even though 9 didn't work, did you check 7? Because 8 times the decimal is 63, so now we're back to 7. Now we're going back the other way on our list, the smaller numbers. So could 7 make 98? 98 divided by 7, yes, was 14. So 7 is the GCF, although you got to look for some variables that are in common. Let me break out my highlighter here. Do you see what I see? The R shows up on both. The S does not. S is on the first one, but not the second one. W is also on both, so this one's different from the other ones. There were 2 variables that were in common, so the GCF is 7RW. All right, that's it for the guided notes on Intro to Factoring Expressions. Thank you for watching. We'll see you next time.